Okay, friends, let's see what this question has for us. Ooh, gotta get to the pen. Mrs. Key. Rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. P of t is the weight of the bird in grams at time t days after its first weighed. Then dB dt equals that. Okay. B is the solution of the differential equation, initial condition 0, 20. I'm going to need that, I bet. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 80 grams? B is the weight of the bird. dB dt is the rate at which the bird is gaining weight. So we just need to look at dB dt. So, actually, I'll just do it right here. dB dt when t equals 40, not when t equals 40, when b equals 40, is 100 minus 40, which is 60, and a fifth of that, so that's 12. And then dB dt when t equals, not t, silly, b equals 20, and not 20, 70. Having problems here. 100 minus 70 is 30. A fifth of that is 6. So then, what you need to write is the bird is gaining weight faster when the bird weighs 40 grams because dB dt at 40 is greater than dB dt at 70. Find the second derivative in terms of b. Use the second derivative to explain why the graph cannot resemble. Okay, so second derivative. So the left side's easy. dt squared. And then the right side, 1/5 will stay. The derivative of 100 is 0. The derivative of b is dB dt. And so we have 1/5 negative dB dt. So that means that's value is always less than 0, right? Well, maybe not always, but mostly less than 0. So let's see. That's 1/5 dB dt. I'll put the negative in front. dB dt is 1/5 100 minus b. And that's going to be, less than 0. For 20 is less than b is less than 100. So b is concave down. Always. But I'm going to run out of room, so I'm going to say it verbally. A portion of this graph, some of this graph, a part of this graph is concave up. So there's where your problem is. So you need to write that down. Use separation of variables to find b of t. So it was 1/5 100 minus b. Ooh, I know where our problem's going to be. So it's dB dt is 1/5 100 minus b. That minus is going to be a problem. So first step is separate the variables. So dB dt, 100 minus b. So we're dividing by 100 minus b. 1/5 dt. We have separated the variables. Now we must integrate. Yes. I want to go over here and have a discussion with you. If I'm trying to integrate 1 over 100 minus b dB, I'm going to u sub this. So I'm going to say u is 100 minus b. du dB, dub, is negative 1, which means dB is negative du, which means we'll have an integral of 1 over u du, but negative. That's where your problem is. So then it's going to be negative natural log of u plus some sort of constant. So that negative you need to make sure you remember. So let's go back over here. So we're going to have negative natural log of 100 minus b. The absolute value is simply there to make sure things stay positive. And then the underderivative of 1/5 dt is 1/5 t. Don't forget your constant right there. We know b of 0 is 20. Let's go ahead and find that right now. You don't have to plug it in right now, but I feel like it. So 20, so that's 80. And then c. So c is the negative natural log of 80. And let's see, so a negative natural log of 100 minus b is equal to 1/5 t, minus the natural log of 80. We're going to e both sides, so it's going to be e to the and e to the. And then we can rewrite the e in the natural log. I'm pausing just for a moment. Actually, before I e both sides, I'm going to go ahead and make everything positive. And by make everything positive, I mean change the sign so it will fit like that, just because it'll make me more comfortable. So then you have e to the natural log, that's 100 minus b. And then you have e to the negative 1/5 t times e to the natural log of 80. Now e and natural log are inverses, so that's 100 minus b. E to the natural log of 80 is just 80, e to the negative 1/5 t. If we solve for b, let's add the b, 100 minus 80 e to the negative 1/5 t. And we have met what this question asked us, and we are done. Ooh, a bunch of areas. Figure above shows the graph of f prime, so that is f prime. Derivative of twice differentiable on a closed interval. We have horizontal tangents, where it looks like it. Areas are given. Function f is defined for all real numbers and satisfies f of 8 is 4. That's important. Find all values of x on the open interval where f has a local minimum. Okay. So f has a min when f prime goes negative to positive. I don't have to worry about endpoints because it's an open interval. So f has min at x equals 1, 2, 3, 4, 5, 6. And is that it? Yes. Determine the absolute minimum. Okay. Min at x equals 6 or at endpoints. We know that f of 8 is 4, because we are told that. F of 6, therefore, can't add. F of 6, therefore, to get to 8, we have to add 7. No, sorry, to get to 4, we have to add 7. So that means we're at negative 3. Because if we're at negative 3 here and we add 7, we get to 4. And then here, we go backwards 3 to get to negative 3, so that is 0. We gain 6 to get to 0. So we're at negative 6 there. And then we gain 2 to get there, so we're at negative 8 there. Let's verify. If I start at negative 8 and I add 2, I get negative 6. If I then add 6, I get 0. If I then add 3, I don't get negative 3, so I messed up right there. Oh, subtract 3, sorry. Subtract 3, that's right. So 0 minus 3 is negative 3, so negative 3. And then if I add 7, I get 4. So I have done everything that's been asked of me. So f of 0 is negative 8. Absolute min is negative 8. Happens at x equals 0. On what open intervals is the graph concave down and increasing? So f is increasing if f prime is greater than 0. So that is from 0 to 6, and no, not 6. 1, 2, 3, 4. I can't count. 4, and then 6 to 8. I guess that should be a bracket there. Don't worry about the brackets and parentheses, not a big deal. F is concave down. If f double prime is less than 0, you can also say f prime is decreasing. You don't have to put this part in parentheses. That's an if. For some reason, the if is not coming up. So f double prime is less than 0, or f is prime is decreasing. So that occurs 0 to 1, 3 to 5, and that's it. So then f is increasing and concave down. 0 to 1, and 3 to 4. Function g is defined as that. If f of 3 equals negative 5 halves, find the slope of the line tangent to the graph of g. Okay. So that means we got to do chain rule. So g prime is 3f prime. I'm going to put an x there just to make myself comfortable. Squared times f of... Don't change the inside, you goofball. 3f of x squared, because of power rule, and then f prime of x. So then g prime at 3 is 3f of 3 squared times f prime of 3. And f of 3 is negative 5 halves. So that's 3 times 5 halves squared. And then f prime of 3 is 4. And I'm done. I could find that number. 2 squared is 4, so that's going to be canceled out. 25, so it's going to be 75. But I don't need to. Did it. Okay. Last one for this. Consider the curve. Okay, I've considered it. Show that the derivative is that. Okay. So the derivative of y squared is 2y dy dx. The derivative of 2 is 0. Product rule there. The derivative of x is 1 times y plus x times dy dx. Let's collect the dy dx's on the left. So 2y dy dx minus x dy dx equals y. Factor dy dx, 2y minus x is y. And then the last piece, dy dx, is y over 2y minus x. Next, find all points on the curve where the line tangent to the curve has a slope of 1/2. So for part B, I need y over 2y minus x to equal 1/2, which means y equals y minus 1/2 x. And that means x equals, so the y's will cancel, right? And that means x equals 0. And if x is 0, then y squared is 2. Y squared is 2. So the points are 0, root 2, and 0, negative root 2. Don't forget plus or minus. What do we got next? I'm going to move this over here. Show that there are no points where the tangent line is horizontal. So for C, if tangent is horizontal, dy dx equals 0. And that implies y equals 0. If y equals 0, then 0 squared equals 2 plus 0. 0 equals 2. But 2 does not equal 0. So y cannot equal 0. So dy dx cannot equal 0. It has a lot of not equals. Alright, and the last part. Let x and y be functions of t related to that. So dy dt is 6, dx dt we need. So I need y squared is 2 plus xy. I've got t equals 5, y equals 3, dy dt equals 6. And I want to know dx dt. Okay, so let's do it. So the derivative, so 2y dy dt, the derivative of 2 is 0. Derivative of x is dx dt, y plus x dy dt. So y is 3. 2 times 3. dy dt is 6. dx dt I don't know. Y is 3. Ooh, x I don't know. And then dy dt is 6. But wait, do I know x? If y is, let's go to here. I'm going to do it in yellow, which is a terrible color. If y is 3, that's 9. 2 plus 3x. So that means that 9 minus 2 is 7. So 7/3. 7/3. So you don't have to simplify this. You could just kind of subtract stuff and go from there. But I'm going to go ahead and simplify. So that's 18 times 2 is 36. It goes 3 dx dt. And then 6 over 3 is 2, so that's 14. 36 minus 14 is 22, divided by 3, and that is dx dt. And we are done.